So now we have the unit circle. This is our blank unit circle, and we're going to fill it in with all of the critical information. So first, we are going to start with our degrees and our radians. So, we'll start with 0 degrees here. All the way around the circle is 360. And so let's start cutting the circle up. Halfway over here would be 180. Up here, half of half would be 90 degrees. And that means down here, 90 degrees past 180 is 270. Now at every other angle here, we're either cutting in half or thirds. So if we take 90 and divide by 3, we get 30. So it would go 30, 60, 90, 120, 150, 180. And then the ones in between them are 45, half of 90, and 135, halfway between 90 and 180. Similarly down here, we'll go up by 30s, so this is 210, 240, 270, 300, 330, and then going exactly 45 degrees after 180 is 225, and then 45 degrees after this is 315. Okay, so some facts about degrees and radians. A pi radians is worth 180 degrees. And then that means 0 degrees is 0 radians. So instead of thinking in terms of degrees, we're thinking here we have 1 pi, which is half of a circle. So if I cut half of a circle, I have pi over 2 here. Then if we cut half of a half, we have pi over 4. And so these we're counting by fractions. 1/4, 1/2. This would be 3/4 of a pi. And then we start thinking about fractions in terms of thirds. So 1/3 of 1/2 right here would be pi over 6. And then we count by 6. Pi over 6. 2 pi over 6, which really would just be pi over 3. 3 pi over 6, which is a half. 4 pi over 6, which is 2 pi over 3. And then we have 5 pi over 6. Okay, so down the bottom here, in radians, we have pi, and then a full circle would be 2 pi's. So if we go 1.5 pi's, that would be 3.5 pi's. Then we start splitting this up even more. So this would be 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, which is already 3 pi over 2, 10 pi over 6, which is 5 pi over 3, 11 pi over 6. And then we have a pi and then 1/4 more pi. So this is going to be 5/4 pi. This one right here, 5/4 pi, 6/4 pi, 7/4 pi. Okay, now those are all our angles here. One thing to keep in mind, books will often ask you to convert between degrees and radians. So just keep this in mind that 1 radian, pi radians is the same as 180 degrees. So let's say that if I had, I don't know, pi over 6 radians, and we want to switch this over into degrees. What you can do is multiply by 180 degrees all over pi radians. The idea here is that 180 degrees over pi radians is actually a fancy one because they're the same thing. But if you have ever taken a physics class before, the units are going to cancel, And so you just times this together to get your total degrees. The pi's are going to cancel, and so this would be 180 divided by 6 degrees, which is 30 degrees. Okay, and likewise, if I ever give you like 23 degrees, you can still multiply by pi radians all over 180 degrees. Now you have a degree over a degree, and you just have to work it out to figure out the total radians. Okay, so back to the unit circle. You're going to be traveling around the unit circle, and you'll need to know the x and the y coordinates of each one of these spots. So this right here is the origin 0, 0. If I go over 1, it's going to be 1, 0. So this one up here is 0, 1. This spot is negative 1, 0. And this is going to be 0, negative 1. Okay. Now, what's the point here? The thing you need to keep in mind is that cosine is your x and sine is your y. So here's what I mean. When you look at the unit circle, you're going to be rotating a certain amount of degrees. The radius of the circle is always 1. It'll start rotating positively around the circle. This right here is positive degrees. And then, once you reach a point here, this distance right here is your cosine of theta, and then this distance right here is your sine of theta. Another way to say this point right here is cosine of theta, sine of theta. Now because of this, whatever is in the cosine or the x value, that's what you'll give if someone is asking for a cosine of that angle. For example, going back up here, if I asked for the cosine of 90 degrees, well, we would look up at 90 degrees and we'd think, well, what's in the cosine? The cosine is the x value. So cosine of 90 degrees is, the answer is 0. If someone asks for the sine of 90 degrees, you still go to the same point, you just give the y value. So if someone said cosine of 180, you go over to 180, that's the x value. Alright, we have to fill in these other points on the unit circle. And I want to show you actually how they come about. So, like I said, if we did 30 degrees, that means we would have traveled up to this line right here. And we would have a triangle, right triangle, that looks like this. Alright, so I'm going to redraw this triangle. Okay, now we know this is 30 degrees, and we know because this circle is a unit circle, the radius is actually 1 right there. Okay, we can actually figure out what the width is and the height is by doing some geometry. Well, first of all, we know if this is 30 degrees and this is 90, this is 60 to add to 180. And if we pretend that this triangle was reflected over like this, we would have a side 1 over here, and this would be 30, and this would be 60. So this actually turns out to be an equilateral triangle, because all the angles are the same. So this side right here is a length of 1. What does this mean for sine? Well, the sine value then has to be 1/2. So at this point, we know the height is 1/2. Now how would we find the width? Pythagorean theorem. X squared plus 1/2 squared equals 1 squared. Oops. 1/2 squared is 1/4. I subtract 1/4 on both sides, and I end up with 3/4. And if I square root, I get x equal square root of 3/4. Now, one thing you could do with square roots, you can square root the top and bottom separately, so this is actually square root of 3 all over the square root of 4, which is 2. So the x value is square root of 3 over 2. Okay. So square root of 3 over 2 goes here. This goes here. Now, the cool thing about this is, if you look at this triangle right here, this triangle is actually the same triangle, just flipped around. So this has the same numbers, but the sine and the cosine are flipped. Not only that, but if you look on the other side, you're going to have the same exact point here, the same exact height, which is square root of 3 over 2, but your x value is negative. Okay, and same thing here. This is negative square root of 3 over 2 and 1/2. All right. Not only that, you can start flipping it over the x-axis. Here, we'll have square root of 3 over 2, negative 1/2, because it'll be this point reflected down. And similarly, the 1/2, negative root 3 all over 2. Then lastly, you're going to have negative root 3 over 2, negative 1/2, negative 1/2, negative root 3 over 2. So, if someone says, I need the sine of 60 degrees, you would go to this point right here, you'd look at the y value. Sine of 60 degrees is root 3 over 2. Okay, so last thing here, we have to find these halfway points. So, there's another easy way to think about this. On the unit circle, if I drop this down and made a right triangle, it's going to be a 45-degree triangle in the corner. Okay, now the 180 rule in triangles forces this to be 45 degrees as well. And if you know about this triangle, if you just think about it, this side has to be the same as this side. Okay, and that makes sense because it's 45 degrees. Now we're going to do x squared plus x squared equal 1 and use Pythagorean to figure out what x is. I can combine like terms here. That's the trickiest part. X squared plus x squared is 2x squared. Divide by 2, and then I have to square root. Now, if I think of this square rooting it separately, I'm going to have 1 over the square root of 2. And remember, we got to rationalize this, so we're going to actually multiply by root 2 over root 2, so that would be square root of 2, because 1 times square root of 2. And then root 2 times root 2 is 2. Okay, finally, we have our answer. Both the height and the width is the same there. So here we'll have root 2 over 2. This one, since it's reflected over the x, will be negative. And then down here we'll have negative, negative. This will be positive root 2 over 2, negative root 2 over 2. Alright, so you're going to start seeing problems where they say, the sine of 3 pi over 4. You go along your circle, you get to the point 3 pi over 4, and then you think if it's sine, I need to give back the answer. That's the y value.